So in this question we have w, x, y and z, which we're told are integers, and we're given some conditions which relate these integers. So w is strictly less than x squared, x is strictly greater than y squared is strictly less than z squared, and x is strictly greater than z. And we want to know which of the following must be true out of a, b, c, d and e. So first of all, I've just written out under here the four inequalities that we're told must be true. And I've just written them exactly the same, except I've made sure the signs all point the same way without changing the inequality, just so we can see what's going on better. So the way we're going to tackle this problem is we're going to try and find some values of w, x, y and z which work or which don't work, so that we can see which is true. So for example, if we can find a w and an x with w greater than or equal to x, such that all of the other conditions up here hold, then we must know that a is not necessarily true. So why don't you pause the video and have a go at trying out some different values of the various integers to see if you can work out which of a, b, c, d and e must be true. Pause the video and have a go at doing this now. Okay, so for a, we're going to try w equals 3 and x equals 2, because then w is clearly bigger than x. So if this works, then a can't be the one which we want. So it does work because w is less than x squared, which is 4, and that's the only condition we need to check. So clearly it can't be a. So try and do the same thing now for b. Okay, so we want to pick a big X and a small w. So that this works. So for example, if we have x is 20, y is 4 and w is 2, then clearly y is greater than w because 4 is greater than 2. But if you go through, all of these conditions do hold, and therefore it can't be b. So for c, we know that we can have this work. So in C, we're told to try w being less than z, but here we can have z less than w less than x, e.g. with 2, 3 and 4, where all of these conditions hold, so it can't be C. So we're just going to skip D for a moment and look at E. So for E, we have that y is less than z, so can we find y greater than z that works? Well, yes, because if, for example, we have y is -1 and z is -2, then clearly z is less than y, but z squared is greater than y squared, because when we square this becomes 4, which is greater than this squared, which is 1. And so it can't be E, and therefore by process of elimination we must have that the answer is D. We can also just see that the answer must be D, because if we look at the condition D, so x being strictly greater than y, and this must be true because x is strictly greater than y squared, so it must be greater than y. And so we get our final answer of D.